I'm Peter Dubruel. I'm heading the Polymer Chemistry and Biomaterials Research Group at Ghent University, and we're one of the partners in the European project called DERMA. In the DERMA project we're trying to develop novel wound dressings, and to realize that various aspects have to be looked into. First of all, novel materials have to be developed. We're also looking at different ways of processing those novel polymers into a final material, and of course also some other aspects like capturing of odors which are typically present in a wound environment are being tackled in the project by various partners. The role of Ghent University in this project is actually to develop novel polymers that can be used as a hydrogel material. And the hydrogel typically is a material that takes up very large amounts of water without actually dissolving. And what we want to try to do in combining novel hydrogels with certain processing technologies to make them into a final wound dressing is to mimic actually how certain parts of our body are composed. So we're quite often trying to mimic the so-called extracellular matrix in those wound dressings. So at present we are in the first phase of the project, in which we are developing different hydrogel building blocks for the final wound dressing material. In the next steps, next months of the project, we will be applying those to really look what aspects have to be taken into consideration to go from the selected and the developed materials into a final wound dressing. And there, polymer processing technologies will be looked into, electrospinning being one of the more novel ones for wound dressing. And this is one of the technologies that is being developed in the DERMA project. The project indeed has various outcomes. First of all, we want to develop novel polymers that can be applied to develop this final wound dressing material. Now, starting from a polymer and making a final wound dressing means that you have to process those materials using certain technologies to end up with a final material. And in our project, we will be applying, among other, electrospinning to realize that. Very important also is that some of the outcomes of the project would be the property of the polymer to actually capture odors that are typically being present in a wound environment. And very important is also the fact that the final wound dressing should have a diagnostic purpose. If certain infections are taking place at the site of the wound, the final wound dressing to be developed should actually enable doctors and medical personnel to indeed have a visual view and inspection on whether those infections are taking place, so that certain measures can be taken directly after tracing such an event. The collaboration in this project, and for us as an academic partner, is really something novel. The fact that the final material is not only looked at developing novel materials, adding certain functionalities to those wound dressings, but also making sure that the final material is really something like a piece of textile that can be actually brought in contact with certain patients. It's for me the first time that we are involved in such a project where really all the aspects from the food chain of a wound dressing are being tackled. Novel materials being developed, they're processed into a final shape. Different functionalities like odor capturing, diagnostic capabilities of the wound dressing, but also combining all those technologies into a final textile material, and therefore the entire process of how certain materials can be literally or virtually glued into a final textile material is also one of the aspects which is being taken care of during DERMA. Science is always, I would say, you start with a big journey and you have a very nice plan which is written up, but once you start executing that science, you always have certain novel findings which you want to implement directly in the follow-up of the project. And from our part, from Ghent University, we have been in the process of patenting a certain technology on polymers, which we now, with the different DERMA partners, want to boost into a final wound dressing material that hopefully in the future will be introduced into the clinical setting for the benefit of patients. What we're actually looking into is a couple of different things. First of all, we are with the different partners looking at the scientific progress made during the last periods of the project. We also have something which is always present in European project meetings, a steering meeting, just to see how timing is actually taken care of, if certain delays have been taking place or not, and how they have to be dealt with. And then of course also tomorrow we will have a meeting with different stakeholders, with different parties that actually would benefit from the final novel wound dressing to be developed. And that can go from patients to companies, and for us as a DERMA consortium, to have their input is actually key to make a successful wound dressing in the long term. With some of the project partners in which we are now involved in DERMA, we already had previous collaborations, and this project is actually a result of previous projects, and actually also some partners were involved, as I mentioned, in previous projects. So some of the partners already knew each other before starting with the project, and that actually gives the project a kickstart, a very quick start. The phase where you have to get to know each other, that phase was not present in DERMA, and actually the entire project benefits very strongly from that. So it's a continued collaboration where we're really aiming at something where the patient could benefit from in the midterm future, I would say. One of the project partners locally here in Portsmouth is actually taking care of certain software modules and certain hardware as well, to enable actually certain animations to be developed. As we all know, outreach activities in the scientific field are extremely important to make sure that certain scientific breakthroughs are actually being communicated in a very early stage already to the wider public. But even more, with the technologies that are available here at Portsmouth University, also certain animations can actually be realized. So for example, if a patient would be brought in contact with a certain textile material that contains an hydrogel, then actually the way that this patient is actually moving can be traced in a very straightforward fashion. And in this way we can also learn a bit about how the different textile materials would be behaving when they're brought in contact with patients. So again, the disciplines that are present here locally at Portsmouth are a real added value to the project, to bring or to develop a new generation of wound dressing materials. I think, generally saying, the impact can be to improve the human quality of life, and this can be subdivided in various different sub-objectives. First of all, I think if a wound dressing can be developed that could capture odors, that of course the psychological impact of a certain wound on the patient would actually drastically reduce. Secondly, if an infection occurs with the current generation wound dressings, this cannot be diagnosed at an early stage, and this is where DERMA will realize a breakthrough, with the final aim of the project being wound dressings that can actually diagnose infections at a very early stage after the onset. And a very last impact aspect would actually be the fact that the type of dressings that we would be developing would actually be requiring fewer changes of the wound dressing over time, which again decreases the patient discomfort when a certain treatment has to be started up.